Okay, question 6, bit of a strange one. So we got 4 points, A, B, C and D, which are -7, -7, 8, -1, 4, 9 and -11, 3. We want to prove that ABCD is a rectangle. So, it's 4 marks. What do we know about rectangles? We know that opposite sides are the same length and parallel to each other, and the two pairs of sides are perpendicular to each other. So, what we can do is we could either find the gradients of each side and show that the gradients are perpendicular between the two pairs of sides, or we could find lengths of sides and show that the opposite sides to each other are the same lengths, and then we would need to show somehow that the angles between the pairs are 90 degrees. So the way that I'm going to do this is by finding the gradients of, first of all four sides. So, gradient is difference in y over difference in x. So the gradient of A, B, well, that's going to equal, if we do -7 -1 over -7 -8, then we get -6 over -15, which simplifies to positive 2/5. Okay, let's find the gradient of BC. So that's going to be, if we do 9 minus -1 over 4 minus 8. And then we get 10 over -4, which gives us -5 over 2. Next, let's find the gradient of CD. So, that's going to be, let's do 9 minus 3 over 4 minus -11. So that's going to give us 6 over 15, which gives us, again, 2/5. And then finally, let's find the gradient of DA. So that's going to be, let's do 3 minus -7 over minus 11 minus minus 7. So that's going to give us 3 minus minus 7 is 10 over minus 11 minus minus 7 is minus 4, which gives us minus 5 halves. So what we can see then is that AB is parallel to CD. So AB and CD are parallel, and also BC and DA are parallel. So the reason that we know they are parallel, or that the pairs of lines are parallel, is because they have equal gradients. So what we can say now is, so ABCD is at least a parallelogram. So what we now need to do is show that these gradients are perpendicular, which will then prove that we have a rectangle. So I'm going to clear this up. Okay, so if ABCD is a rectangle, and then in the pairs of sides are perpendicular. Now, perpendicular gradients multiply two minus 1. So, if we multiply our two gradients together, so the minus 5 halves times 2 fifths, we do indeed get minus 1. Okay, so we should finish off with a concluding statement. So let's say, so opposite sides of ABCD are parallel and the pairs meet at 90 degrees. So A, B, C, D is a rectangle. Go. Okay, then part B wants us to work out the area of ABCD. So, area of a rectangle is base times height. Probably not big news at A level. What we need to do though is work out the lengths of this rectangle. So, point A as coordinates, so -7, -7. Point B as coordinates, 8, -1. And then we're also going to use point C. So point C has coordinates 4, 9. Okay, so let's work out the length of AB. So it's Pythagoras really. Find the lengths between the coordinates, square them, add them together, and square root. So the length between the x coordinates of A and B is 15. So we get 15 squared, and the length between the y coordinates is 6. So we're doing 15 squared add 6 squared, square rooted, and that's going to give us root 261. And then we're going to do the same for the length BC. So between the x coordinates, we have a length of 4. So we're going to do 4 squared. And then the height between -1 and 9 is 10. So it's 4 squared and 10 squared. Square rooted, which is root 116. So the area is root 261 times root 116, which gives us 174. Cool.